This is the OCR Level 3 FSMQ in Additional Maths. There's only one paper, and this is for 2019 onwards. This is a sample paper for this. Now, 2020 and 2021 don't exist. So I think the only public papers, if you are practicing this for, say, 2023, right now are the sample and the 2019 papers, which I'll do at some point. They might already be on the channel by the time I'm watching this. There's only one paper, as I said, it's 2 hours long, and you are allowed a scientific calculator, which I'm not going to talk about because I've made my feelings on that pretty clear in the past. This is the formula book. I think it changes every time there's a paper because this is different to the 2019 one, so I think it's giving you what you need for this paper, which is kind of interesting. But anyway, let's go into it. This is just an iterative formula. You put in U3 into here to get U4 out, so you just do the next one equals 2 times the previous one minus 1. 2 times 12 minus 1 is 23. And then you just do it again. You put in 23 into the thing, 2 times 23 minus 1 gives you 45. And then the next one again, you get a 9, 2 free marks. Good, next one. Here we're going to do a binomial expansion. There are two ways to learn this. You either do Pascal's triangle and say that the sixth row of Pascal's triangle is 1, 5, 10, 10, 5, 1. Or you say you're looking for 5, choose 3, or 5, choose 2. It doesn't really matter. You can type that into a calculator and get 10. And then, of course, you're just looking for 2 of those, 3 of the 3x's, so it's going to be 2 squared times 3x cubed, all cubed that is, times by the number here, 10. So 10 times that, and you eventually end up getting, of course, you don't need to do this because you've got a calculator, you've got 1080 is going to be the answer. And that's good. Okay, cool. Number 3, differentiate, so you times 3 by the 1 that should be here to get 3x, bring that down to 2, so that's going to be 3x squared. This is an x to the power 1 times by 2 for 2. Bring 1 down to 0, x to the power 0 is 1, so this is just going to be a 2. This is going to go away, because constants always go away. And this is dy by dx. Turning points happen when dy by dx is 0. So, of course, we set that to be 0. And the problem with this is that x squared is always greater or equal to 0. And it's never less than that. So the smallest this can be is 0. When you add 2, you're definitely going to not be 0. And so this is just not going to happen ever. Good. Question 4. No idea what this bold means, because aside from the fact that you could just type this into a scientific calculator, so maybe it's just telling you not to do that. This is x cubed over 3 when you integrate. This is 3x. Just shove in 2 and 1. 2 first into both these things, then take away when you put in 1 to both those things. Just type this into a calculator and you get the answer eventually. Good. Question number 5. First interesting question here. Sketch h against theta. So we're going around like this, and h is the vertical distance up to wherever you are, and theta is this angle going around from here around this way. So okay, we're going to sketch this then. I guess you could put h and theta on either axis, but I chose to do it this way. When theta is 0, and you're just going straight down, h is also 0, right? Because there's no height there. So 0, 0 is first. When theta is 90, h is the radius, which is 67.5. Right, so 90, 67.5. When theta is 180, h is the entire distance here, which is 2 times 67.5, which is 135, I think. I haven't really checked that. Next one, when theta is all the way around to 270 degrees, h is just 67.5 again. And then lastly, when theta is 360, h is 0. So we end up with a graph that goes through these points. And now think about this carefully, but when theta increases to start with, like when it starts at 0 and then increases by a bit, you could probably send theta all the way to like 10 degrees or 5 or 10 degrees, and h barely increases at all. So this has a very slow increase to start with. And then the exact opposite up here, when theta is like actually quite far away from 180, h is pretty much already at the top. So there's a very slow, gradual tapered up to the top there and back again. So it's a very small increase here and then a very small decrease there. So it looks a bit like this. Would be my sketch. Got the computer to do it obviously for me. Okay, good. So give an expression for h in terms of theta. Now this you should recognize as being a sine wave or a cos wave more accurately, because if you just flipped this over and then moved it up or down, you could get cos out of this. You could just start with the cos graph and do graph transformations to find the equation of this curve, or you could look at the picture and say that this distance, if we call it d, we can say cos theta equals d over 67.5, so therefore d is 67.5 cos theta. And we're looking for h in terms of theta, but h, of course, is just going to be this distance here, right? Because it's this distance here, which is the same as this here. So h is equal to 67.5, which is all of this, minus this bit. So we can just say that's going to be our answer there. Find the values of theta when h is this, so just plug in 100. This is poor question writing for a couple of reasons. I'll just call OCR out right here. Partly because you can't get these 3 marks unless you get this. That's number one reason why it's poor question mark writing, but also because this is the easiest 3 marks of the entire thing, but they're locked behind the hardest 4 marks. So this is a completely ridiculous question, just putting it out there. Anyway, you put in 100 into here, you rearrange for a bit, you solve for cos, and you get 118.78, which is up here somewhere, which seems to make sense. Read the question carefully, find values of theta, because of course when theta is on the other side symmetrically, the height is also going to be 100 the same way. So all I did was I said, well, there's 118.78, that's what I said, and then 360 minus that gives me the turnaround the other way. So 360 take away this will give me my other answer of that. Good, question 6, right, so just times this by x minus 1 over x minus 1, this one by x plus 2 over x plus 2. Got the same denominator here, we can expand out these two bits, but with the same denominator means we can just put these together. Minus x minus 6x minus 7x, and then minus 12. Good, the question now says that's equal to 4, so times these two things across here, expand all this out, expand it out some more, rearrange. This does not factorize, which is a shame, so you just shove it in the quadratic formula. And it says in exact form, so we're just going to leave it like this, I guess. Good, number 7, so factorize out a 2 from all of these things. Completing the square with a 2 here is not fun, so now just complete the square on this bit, which is going to be x plus 2 all squared, and then minus 2 squared, which is minus 4. This becomes a minus 10, and then times everything by 2 to get 2 and 20. Now what's the minimum of that? Well, we saw this before, but this is positive. This is always positive or 0 because it's something squared and then times by 2. So when x is minus 2, that's when this is at a minimum of 0. And then we can take away 20 to get the minimum of minus 20. Good. This question here, well, if you draw it, it becomes fairly clear what to do. So we're pretending this is AB, and this is B to C, and this is C to A. Show that one angle is 60. Now, it's clear that you're supposed to do some cosine, but which angle do you set the cosine rule up if I call these A, B, and C? Because if you do it for the wrong one, you won't find 60, and then you'll have to find some others, and that will be some extra work, which we don't want to do. But there's a very logical way of working out which one of these must be 60, which is the longer the side in a triangle, the bigger the angle that it's facing. You can almost just imagine this as if you open up these two lengths further apart from each other, this distance must increase, right? And if you close up the distance, the angle here, this length decreases. So that means that A is the smallest angle here, C is the next smallest, and B is the biggest. But of course, if you're looking for an angle of 60, 60 can't be the smallest, because then you have two angles bigger than 60, and then it won't add up to 180. But 60 also can't be the biggest, because then you have two angles smaller than 60, and that's not going to add up to 180 either. So we must come to the logical conclusion here that C is the 60 degrees, because it's in the middle. So C must be the 60, and the other one must be lower, and the other one must be higher. So therefore, if I set up cosine rule like this, I'm guaranteed to hit the 60 degrees, which I do, of course, because I know what I'm doing. And I'll get the answer. Good. Question number 9. So show that this is a factor. Factor theorem says that if x minus a is a factor, then that means f of a equals 0. So if we call this the function of x, and we just need to shove in f of 3 in that case, and what do you know, it equals 0. Good. Hence solve this equation. That means that this thing has a factor of x minus 3, as we've just said. So this thing is literally x minus 3 times some other thing. Now lots of people will be expecting to see some polynomial division here. If you're a long-time fan of the channel, you'll know though that I never do polynomial division because I irrationally hate it. So what I'm going to do instead is just write it like this and then think about g of x a little bit and just say, well, it must be a quadratic, right? Because a linear times a quadratic makes a degree 3 thing. And even more than that, the quadratic must have a single x squared term, because x times x squared makes my single x cubed, and it must also have a minus 5, because minus 3 times minus 5 is plus 15. So all I really need to know about is this bit here, which I don't know, but I think I can work that out fairly easily, because over here there's 1x, and over here I've got minus 3 ax's and minus 5 x's. So I think I can set up that equation there, just considering the x terms. And then I can solve that for a is minus 2, so I get this. And now this I know has a solution at 3, which we've seen. So I just need to set that one to equal to 0. It doesn't factorize, of course. So you can just complete the square root of the formula. It doesn't really matter. You get these two solutions, so those are the 3 solutions. Good. Cool. Question number 10, I believe. Yeah. You have 3 letters, you have 4 numbers, that's 7 options in total. So if there are no restrictions, it's just going to be 7 to the power 4, 7 times 7 times 7 times 7. Couldn't be bothered to work out what that was. If there are exactly 2 digits and 2 letters required and no repeats, how many possible? So I just went, so just say that this is the order, letter, letter, digit, digit. you have 3 choices for the letter first, then 2 choices, because you're not allowed to choose the same letter twice, then 4 choices for this digit, then 3 choices. So just in this setup, you have 3 times 2 times 4 times 3 choices, which is 72. And then I decided to think, well, how many of these setups are there? And there's much fancier ways of doing this, but you can just list them, right? You can just say, okay, let's put the letter here instead, and then let's put it here. Sorry, so keeping one letter here, then the other 2 there. Then let's move this letter into the second bit, and we get this option. We also have this option. Then the final 2 is this option. And I think that's 1, 2, 3, 4, 5, 6 options. So it's going to be 70 times 6, because there's 72 for each of these things. And we have the answer of 432. Good. Question number 7. This is this curve here. Trapezium rule from 2 to 4 using 2 strips. So okay, from 2 to 4 using 2 strips is obviously this. So we have a distance of 1 between them. We have some trapeziums here. This height is 2, so it's going to be 2 plus whatever this is, which is when you put 3 into that. So 2 plus this divided by 2, because it's a plus b over 2 times h. H is just 1, the distance between them, and then the same thing happens here. The last distance is 4. This is the same as this, because this distance is the same on either one. And you just type that into a calculator, you get this. And that is, of course, an overestimate, because the curve goes underneath each of these straight lines. Good. Next bit, you can also just use the formula that's given in the formula book, but who cares? Using a chord from 2, 2 to 4, 4, estimate the gradient x equals 3. Well, the gradient here is clearly just 2 divided by 2, which is 1. Amazing. Determine an estimate that's better than the one that you just did. Well, all you have to do is pick 2 points slightly closer to 3. It feels like they should be symmetrical around 3, but the mark scheme actually didn't say so. I chose 2.4 and 3.6, just because that meant I could draw a picture that sort of looked right, but it doesn't really matter. The distance across is clearly 1.2, and the distance up is just this number when you put in 2.4, which is that. Although you don't even need to work this out, you can just type in this minus that. You could also type in 2 to the power 1.8 or 2 to the power 1.2, just to be fun. Take this one away from this one, and you get this distance here, which is that, and then you just do this divided by that, and you get your answer of this. Good. Excellent. Next one, China Cup's placed. I will just say really quickly here, I didn't think this answer was right when I first checked it, because I thought, of course, the gradient gets steeper as you go along. So I assumed that my answer would have to be more steep than this, because the gradient's getting steeper the further you go along. But actually, because this first estimate is so poor, like this estimate here, it's almost like if you went from 2 to 100, this graph is basically 100 at 2, is basically vertical when you get to 100. This line would be very steep, and you'd be massively overestimating this gradient. So it actually kind of makes sense that it decreases a little bit, even though it at first seemed counterintuitive. But anyway, China Cup's replacement box of 10. Yeah, so this is just binomial expansion theorem, so it's this. So the probability that the number cracked is exactly 1 is equal to, just fill in numbers, n is 10, 1 in 8 to crack, so 0.125, that's 1 over 8 is p, and x I'm looking for is 1. So I just say p of x equals 1 is equal to 10, choose 1, 0.125 to the power 1 times 1 minus 0.125 to the power 10 minus 1, which is 9. Just type that wholesale into your calculator, you get this number. At least 2 are cracked. Now, that means 2 or 3 or 4 or all the way up to 10. Now, the probability of this, probability of 0 being cracked plus probability of 1 being, plus 2 being, plus 3 being, all the way to 10 being is obviously 1, because it just encompasses everything. So all I need to do to find the probability of 2 plus 3 plus 4 and plus 5 all the way to 10 is do 1 minus those 2. And the good news is, I've already worked that one out, and this one is very easy to work out because you shove your x as 0 into these, which makes that 1, and that 10, and you can type this into your calculator quite quickly, and you get the answer. Good, some trig to do, excellent. So, read this carefully. The area of the square ABFE, which is this diagonal slanted one, is 1/600, but it's a square, right? It's a square. So, 1/600, by the way, was a bold way of describing this number. It's a square though, so you just root this number 1/600, which is my new name for it, which is 40. So this has sides 40, 40, 40, 40, but they've told you that this is length 12, so that means that's 28. Good. And now we're looking for the area ABCD, so I know that that's 40, so I just need this length here. Well, okay, if we just call that, y, we have that this is adjacent, this is hypotenuse, so cos of 20 is equal to y over 40 times what it does by 40, and we just end up with this being 40 cos 20, and also this being 40 cos 20 because it's the same, isn't it? Which is this, so now we just do this times 40 and we get that. And then the angle between XE and XF. Now XE is this one and XF is that one. What I just do is just find this slanted angle here, which is tan inverse 40 over 12. It's of course opposite over adjacent, which is that. And then this one on this side is going to be tan inverse of 40 over 28, which is that. And then 180 minus those two things gives you this angle here, which is going to be that. Good. Almost at the end, actually. I think there's only 16 questions. This is in the formula book. I just went through it quickly, but if you've got variable displacement here, that means variable velocity and variable acceleration. You differentiate the displacement to get the velocity. So if we differentiate that with respect to t, we get 48 minus 3t squared. That's the velocity. And if you differentiate the velocity, you get the acceleration. So if we differentiate that, we get minus 6t, which is the acceleration. And so the acceleration when t is 1 is just shove in 1, you get minus 6. The time when it comes to rest means velocity 0. So we go back to our velocity statement and set velocity to be 0, and then solve for that, which is not too hard. Of course, t minus 4 doesn't make any sense, so we'll just go with that. And the distance fallen when the object comes to rest. So again, velocity 0, but it's the distance. We're talking about displacement here. So we have to go back to this, and we say, well, okay, well, we only have this in terms of time, but we know the time it takes to get to rest. So we shove in 4 into this to find the displacement, which will be this. If you just put that in a calculator. And now sketch the thing. Well, okay, so how do I do this? Well, sketch the velocity time graph. So it wants this sketch, which is just an upside down quadratic with a y-intercept of 48. Except we don't care when t is negative, because time negative doesn't make any sense. And we also don't care when the velocity goes to rest. It can't. It doesn't. We're not interested after that. We could have negative velocity, but we're not interested in it. So we'll get rid of all those sections, and we'll be left with this graph here. Good. Last couple of things here. Bought a car for this value, blah, 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 blah. Write down the value of k. So k is, well, when t is 0, you get a to the 0, which is 1. So v equals k. So when t is 0, v equals k. K is 28,000. I mean, it's just the number here. It's just the starting number. Like when they ask you this question, it just is. They do that in A-level maths a lot as well. Show that we can write this thing here as this thing. So we'll take log to both sides. I'm assuming this is log to base 10 since it later clarifies that it is. Log laws say that when you've got a product in a log, you can just say this is the sum of the two. So it's log k plus log a to the power t. And then power law for log means this t can be brought down to here. And I think we end up with exactly what they wanted me to find. Good, we've plotted the graph now. And this is the y-axis, which is cool. So that bit's essentially acting as y, and t is essentially acting as x. So if you have a straight line here, which it looks like it should be, and I know that this is supposed to be a straight line because I've done questions like this before, which also hopefully you should have done as well, we can compare this to this, and we can say, well, okay, x is acting as the t, or t is acting as the x. So that's the gradient bit. That's the y-intercept bit. This is mx plus c. So this is the gradient, this is the y-intercept, and that's the y, of course. So okay, c, the y-intercept there is log k, which I don't really need to know, and m, the gradient, which I am interested, is log a. So if I could work out the gradient of this line, which is of course just this distance here, which looks to be about 4.4 minus 3.6, which is 0.8, and the distance across is obviously just 8. The gradient looks to be minus 0.1. I probably should have put a minus in here, but I know it's minus because it's going this way. Good, so that's m, that's the gradient. And of course I can just shove that in here, raise both sides to the power 10, because this is log to base 10, which I just couldn't be bothered to type. And we get 10 to the power minus 0.1 is that number there. So I think that's my good estimate for A. Use the sums model to estimate the age of John's car, when the value drops below 3,000. So we'll just take, I guess, the formula for, V is the value of the car, right? So we'll shove V is 3,000 into here, I guess. We know our A value, so we can shove that into there as well. Except I didn't even do that. I know log of A is minus 0.1, so I don't even need to know A. I've just put log of A is minus 0.1 into there. I put K as 2,800, because 28, whatever this number is called, into there as well. And then, of course, I can just do this, take away this, divided by 0.1, which is going to be this. So that's going to be my estimate, I think. Yeah. This is the last question. I remember it because there's bits down here that I just didn't know how to do because it's not real maths. Suppose the factory makes this and this, show this. Okay, so unskilled, focusing on unskilled for a second. 20 hours of unskilled. So for every X's you build, takes 20 hours. and for every Ys you build takes 15 hours. This is just focusing on unskilled labor. Now you've got 10 unskilled laborers and 40 hours a week, so that's 400 potential hours. So 20 lots of X plus 15 lots of Y is less than or equal to 400. Less than or equal to because, of course, it could be equal to, but some of them might not work the full hours, so it's going to be less than that. You just can't make them work more than that, so that's going to be our bound. Of course, just divide by 5 at that point, and you get this, which is this. Similar for the other one, I mean, it's just literally exactly the same thing. Okay, good. So we get this. Excellent. Okay, so those are our two things. I put this one red for a reason. The reason is because it's asking us to sketch this, draw two inequalities for these things. So what I'm going to do is I'm going to rearrange them both for Y, and it's just easier if I color them in to know which one I'm doing. And the other one for Y as well. Here I can tell that this number is bigger than this number. So this red graph starts higher and has a steeper gradient because this is bigger than this. So it starts higher and goes down quicker than this one, which starts lower and goes down sort of at a lower speed. I can also work out these points by plugging in Y is 0 into here. If Y is 0, 4x equals 80, x is 20. So that's where I got this one. And Y is 0 in here gives you 2x, 64, so halve it for 32. Also, I'm not bothering to draw the graph over here because I can't build a negative number of x is the number of pi k's, I think. Can't build a negative number of those, can't build a negative number, so it's just over here. Good. Show that making 15 and 14 is possible. So if you drew this accurately, you could just pinpoint that 15, 5 is within here somewhere, or you could just plug 15 and 5 into both of those inequalities and show that both the unskilled laborers and the skilled ones have enough time to do that, which is also fine. That's just what I did. Okay, the factory makes £40 on this and £60 on those. Write down this. Now, I've literally never heard of an objective function in my entire life, and this is why I think other subjects are jokes sometimes. I can pretty much figure out that it's probably just saying 40x plus 60y. So, cool. Yeah, good. Done that. Find the number of each that should be made to maximize the profit. Again, I had no idea what to do here, but I felt like the maximum profit should be around this point here somewhere. So what I decided to do was find this coordinate where these two things meet by setting that equal to that, which is this, just times everything by, I think I times everything by 15 here to cancel all the 3's and the 5's, and then just rearrange this. You get this. So they meet here. Now, you can't build 14.85 bikes. So what I thought was, okay, let's just test the whole numbers near this point here. So test x is 14, and if x is 14, you can go into here to find the maximum y. Now, notice how if this is 14.8, you're limited by the black line. Like if you move x to be 14, you're limited by the black line, not the red one, right? Because this is 14.8, and you have to be in this area here, which I never bothered to shade in, but I don't really care. I don't do geography A level, I'm not interested in that. So you do 14.8, and then you move this way, and you're looking to just be, you're going to be limited by the black line, right? Not the red one, because that increases faster this way. So put in x is 14 into here, and show that the limit for y is 7. You can get 7 point something out, but that means the limit for y is 7. And then work out the profit from that, if you do 40 times 14 plus 60 times 7, which is this. And then instead you move this way instead, so you put in x is 15, but of course this time you're limited by the red line. Like if this is 14.8 and you move a little bit across, you're limited first by the red line if you're going to be in this region here. So you put 15 into here, and you work out that the largest you can put for y is 6. And then you put that into there, and you work out it's a slightly lesser profit. And I think that just means that the answer is 980. I know that's not a complete proof, but looking at the mark scheme, it doesn't seem like there's much more I need to do for the marks there, though it's very hard to actually see what the mark scheme was doing. If you do a joke subject at A-Law, like economics, and you actually do this kind of stuff there, then please tell me what it was that I was actually supposed to do. But the answer is definitely 980, and I'm pretty happy that I've shown that. All right. Good. Okay, thanks for watching.